In this video, we're going to talk about waves. Waves are disturbances usually set up by vibrating bodies which result in the transfer of energy. Now, they occur both in material media and free space. We have classification of waves based on production mode. The first one is transverse wave. In this type of wave, vibration is perpendicular to the direction. Example, surface water wave, electromagnetic wave. Example of electromagnetic wave is light and radio wave. Another one we have is longitudinal wave, a type of wave in which the vibration occur in the same direction, that is parallel as the direction of the wave. Example is sound wave, speech, earthquake, tidal. So we also have classification of waves based on mode of propagation. The first one is stationary wave. Is a type of wave that cancels out each other at a point in motion. The second one is progressive, the type of wave that continues in the motion over time. Now we have characteristics of wave as well. Number one is reflection. When wave collide with an obstacle and bounces back, reflection happens. Second one is refraction. That is bending of wave as it moves from one medium to another with varied density. So the difference in density, you have refraction. This third one is diffraction. That's bending of wave around an obstacle, resulting to an increase in wavelength. Another one is interference, the ability of two traveling waves to interact with one another, resulting in either cancellation, that is destructive, or reinforcement, that is constructive. Now, generally, a progressive wave equation is giving us y equal to a sine into theta plus phi. Y is vertical displacement of the wave. When we have something like this, so this is y, this is x, and A is the amplitude, that's the maximum displacement of a wave, while this theta is what we call angular displacement, and it is giving us omega t. Phi is the phase difference. The phase difference is giving us 2 pi over lambda x. X is the horizontal displacement. Now, since we have this, it means we can substitute this and this by saying that y is equal to a sine. Instead of putting theta now, we can replace it with omega t plus or minus. Instead of putting phi, we can replace it with 2 pi over lambda x. So this is another way. In this is the angular velocity, this is the time taken, this is the length, that's the wavelength. Okay, now we can also, since omega also is giving us 2 pi f, we can still replace omega here with 2 pi f by saying that y is equal to a sine into, instead of this, we say 2 pi f t plus or minus 2 pi over lambda then x. So these are ways we can represent a progressive wave. This is the frequency, this is a constant, this is a constant. So before we get into the calculation aspect, I want us to look at a few parameters on the wave. The first one is amplitude. It is the maximum displacement about a mean position that a wave can undergo during its motion. You know, since it is distance, it means the unit is in meter. The second one is wavelength, lambda. the points, or we can say it is the horizontal distance between the successive peaks. That's the wavelength. So the next one is cycle. So cycle, like when a wave has undergone maximum displacement up and then maximum displacement down and returns to its original position, then it has undergone a cycle. The next one is period. That's the time taken, or the time it takes a wave to complete one cycle of its motion. So the next one is phase. We use psi for it. Phase. It is the angular distance between a wave that has zero displacement at time equals 0 and that which has non-zero displacement at same time equals 0. There's another one is a frequency. Now frequency is the number of cycles a wave completes in 1 second. The unit is hertz. We also have velocity, v, or speed. It is the speed at which a wave crest or peak travels. So now, for example, this question says plane progressive wave is represented by the equation y equals a sine this in meters. Determine 1. The frequency of the wave, 2. Its wavelength, 3. Speed, 4. Period, 5. Phase difference, 6. Angular frequency, 7. Phase at time 0.5 seconds and y equals 15 cm. The very first thing we will do is to write the equation y equals a sine into 80 pi t minus 80 pi over 16 x. Now, if we can compare y equals a sine into 2 pi ft minus 2 pi over lambda x. If we compare this, the first thing they want us to find is the amplitude A. So amplitude A, which is here and here. And for amplitude, this is amplitude. Sine, this is this. This is this. So we compare. If we compare it, now the first question, they say we should calculate the frequency, f. So for us to calculate f, where f shows is here and also here. It means here is equal to here. So we can say that 2 pi ft is equal to here. That here is here. 80 pi t. Here now, pi is common because this is positive. If one comes to the other, it becomes negative. So positive, negative, they will cancel out. The same thing happens to t. This cancels out this. So what remains is 2f is equal to 80. So 2f is equal to 80. Therefore, f is 80 over 2, which is 40 Hz. So for the second one, they want us to get the wavelength, which is lambda. Now from the equation, the two equation, where does lambda stay? Lambda is here. So it means it's here. It means this place is this place. So what we're going to do is that 2 pi over lambda is equal to 80 pi over 16. So here pi is common, can cancel out. So you can cross multiply, or 2 can cancel itself, 1 cancel out. Okay, let's cross multiply to make it easier. If we cross multiply, we'll have that lambda times 80. We'll have 80 lambda is equal to 2 times 16. So that's 2 times 16. So we have that 80 lambda is equal to 32. Therefore, lambda is equal to 32 over 80. One will resolve. We can have that 16 here is 2. 16 here is 5, so 2 over 5, or we say 0.4 meters. So that is the wavelength. The third one they want us to get is the speed, v, and v is equal to f lambda. So we simply, f is 40, so we say 40 times, this is 0.4, which will give us 16 meters per second. So the next thing to calculate is the period t. The period t is giving us 1 over frequency. So which we have 1 over, our frequency is 40 Hertz, which will give you 0.025. Period, remember, is time. So say seconds. So the next thing they want us to calculate is phase difference. So the first difference at 4. Let's check the question again. Phase difference at 4 centimeters. Okay, phase difference at 4 centimeters. Now, remember from the equation, we have 80 pi x over 16. So now, at 4 centimeters means that x is equal to 4 centimeters. If we convert it to meters, it becomes 0.04 meters. So this becomes equal to 80 times pi is equal to 180. 180 times 0.04 over 16. If you calculate all of this, you get 36 degrees. Another way you can do this is by putting it in rad, which is radian. In that case, pi becomes 3.14 times 0.04 over 16. When you do that, you're going to have 0.628 is now in radian. This is in degrees. This is in radian. Now, the next thing they want us to calculate is angular frequency. Angular frequency, remember, is omega t. So, in that equation, if we check it, it means what is there is 80 pi t. That's what is in that place, 80 pi t. Another way we can represent this is, we say, or pi is in radian. We say 80 radian per second. So for us to calculate the phase, what we do is we write the equation. Remember, y is now 15 centimeters, which is 0.15 meters. 0.15 meters now is equal to, we were not given the amplitude. Let's assume it is 0.5 sine into 80 times pi is 180 times t is 0.5 seconds, we place it, minus 80 times 180 over 16 times x. We are now looking for the value of x. X is what we're looking for. So what we'll now do is we resolve here. 0.15 is equal to 0.5 sine. If we resolve here completely, we'll have 7,200 minus, if we resolve this place, we'll have 900x. So this can come over here, 0.15 over 0.5. So we have is equal to sine into 7,200 minus 900x. So sine coming over here is already 0.3. We have sine inverse of 0.3 is equal to 7,200 minus 900x. Sine inverse of this should give us, let me press the calculator, should give us about 17.46, which is equal to 7,200 minus 900x. Let me turn, so that what we will now have is that we make 900x subject of the formula. So 900x is minus. If it comes over here, it becomes plus. So is equal to 7,200. 17.46 is positive. If it comes over here, it becomes negative 17.46. So if we resolve here, we're going to have about 7182.54. Remember, 900x. If we now make x subject of the formula, we'll have 7182.54 over 900. So x is 7.98 meters approximately. So please do well to subscribe to my channel. Thank you.